Okay, we've just got three more identities that we need to have a look at. In this one, we're working with the expression of sine of 4 theta. And I notice that 4 theta is expressible as 2 times 2 theta. In other words, this is a double angle. It's double of 2 theta. So let's apply the sine of a double angle formula. We know that that becomes 2 sine of the angle, cosine of the angle. Alright, well now we've got of course, two double angle formulas within. So let's change the sine of 2 theta to a 2 sine theta cosine theta. And at this point, I think I'm going to sneak a peek at the right-hand side to look at the form. I notice that they've only got one factor of cosine, but they have a sine cubed in there. It implies that we need more sines than cosines. So because I've got a choice for cosine 2 theta, right? You remember that cosine 2 theta can be expressed either as cosine squared minus sine squared, or it can be replaced as 2 cosine squared minus 1, or it can be expressed as 1 minus 2 sine squared. I'm going to take this third one, because that's the one that gives me a higher power of sine. So let's change cosine 2 theta then into 1 minus 2 sine squared. Now, and I'll notice that the cosine factor has been left out alone, so I'm going to leave my cosine factor right here, out alone in front. What am I left with is 4 sine theta, which is distributing to the 1 minus 2 sine squared theta. And that gives me cosine of theta, and the 4 sine theta times 1, and the 4 sine theta times negative 2 sine squared gives me my required 8 sine cubed theta term. And there's my right-hand side, thus the identity is proved, or QED, if you want to be a little bit snobby or sophisticated. Alright, number 62. Again, we can see that there is a double angle formula in there. So 1/2 times sine of 2 theta we know is 2 sine theta cosine theta. And of course the 1/2 and the 2 are going to cancel, leaving me with this expression. Now, in order to get this into the right-hand side, well, I can see that I need to have a factor of sine theta plus cosine theta in the denominator. I don't currently have a fraction. So let's artificially inject that factor in by multiplying the top and the bottom by sine theta plus cosine theta. That's going to create that denominator term that I was looking for. And so this, of course, is like all over 1, isn't it? So let's multiply the numerators. It's going to be FOIL, isn't it? So 1 times sine and 1 times cosine. And then we've got negative sine theta cosine theta times sine. Gives me a sine squared and a cosine. And I've got negative sine theta cosine theta plus cosine theta. Oh, sorry, multiplying by that, so that gives me a sine theta and a cosine theta squared. And this is all over my denominator of sine theta plus cosine theta. Alright, all I've got to do then is somehow manipulate the top so it looks like a sine cubed plus cosine cubed, and I'm good to go. Well, in order to get a sine cubed, I suspect that I'm going to have to work with this term right here. If I change this cosine squared into a 1 minus sine squared, then my sine times the 1 minus sine squared, that will generate a sine cubed term. Similarly, in order for me to get a cosine cubed term, I've already got one single factor of cosine. If I change this sine squared into a 1 minus cos squared, then my cos squared would multiply the cosine, and that would give me my cosine cubed term. So let's give that a try. So I can't do anything with the sine and the cosine, but I'll change my sine squared into a 1 minus cosine squared, and I'll change my cosine squared into a 1 minus sine squared. All over sine plus cosine. Alright, let's expand. So I've got sine theta plus cosine theta minus 1 cosine theta, negative negatives. That gives me a positive cosine cubed. And then negative sine theta, negative times negative, that's a positive sine cubed. All over sine theta plus cosine theta. And now for the fun part, my positive sine theta and positive cosine theta will cancel with my negative cosine theta and my negative sine theta. And that leaves me exactly what I'd hoped for. I've got a sine cubed and I've got a cosine cubed left alone at the top, all over sine theta plus cosine theta, yielding the right-hand side of the identity. And the last one that we've got to look at is number 64. So let's start with the left-hand side, cosine plus sine over cosine minus sine minus cosine minus sine over cosine plus sine. Alright, well, my immediate instinct is that I should get some common denominators here. And so anytime that we're adding or subtracting fractions, let's find a common denominator. And so the top of the first fraction is going to need to multiply a factor of cosine plus sine. And my second term will need to multiply by a factor of cosine minus sine. Alright, and this is all over my common denominator, cosine minus sine and cosine plus sine. Alright, let's do a little bit of expansion here. So in my numerator now, as I FOIL this out, I've got cosine squared plus 2 sine theta cosine theta plus sine squared. And then I'm subtracting. I'm going to leave the second expression in brackets to help me FOIL. I've got a cosine squared minus 2 sine theta cosine theta plus sine squared. All over that same denominator, which I guess I'll expand at this stage. Cosine squared minus sine squared, because it's a difference of squares, so the outer and the inner terms will cancel. Now observe that I have a cosine squared and a sine squared here, so that's going to give me a total of 1, and I've still got 1 plus 2 sine theta, cosine theta. And now the expression that I'm subtracting, I've got cosine squared plus sine squared, that again is a 1. Not sure this step actually saved me any time, but oh well. Alright then, so my 1, my positive 1, is then subtracting a 1, so those are going to cancel. And my 2 sine theta cosine theta is subtracting a negative, meaning adding a 2 sine theta cosine theta. This leaves me with a total of 4 sine theta cosine theta on the top, and cosine squared theta minus sine squared theta on the bottom. If I factor out a 2 from the top, and I'm kind of doing this, if I look at the right hand side, I can see that a factor of 2 has come out. So I've got 2 times 2 sine theta cosine theta over cosine squared theta minus sine squared theta. You might now recognize the numerator as being a sine of 2 theta, and you might recognize the denominator as being a cosine of 2 theta. And of course, sine of an angle over cosine of that same angle is going to equal tangent of that angle, and we've got the right-hand side as required. Alright, I hope that these proofs to the identities have made sense to you. I hope that you're beginning to see some patterns to the strategies. Remember that we're looking to do things like finding common denominators, we're looking to do things like factoring, we're looking to look for opportunities to use Pythagorean identities, we're looking to, where necessary, change everything into terms of sine and cosine, and my favorite strategy is to sneak a peek on the right-hand side to see what factors are over there so that I can possibly artificially inject them into my left-hand side on the top and the bottom, and then simplify the rest of it, leaving that factor in place, and with some luck everything will cancel and I'll be left with the right-hand side. Okay, thanks.